In today's class and video, we are going to look at the basic instrumentation of the spectrophotometer. So we'll start by looking at what a spectrophotometer is. A spectrophotometer is an instrument that is used to measure or quantify the amount of light absorbed by a test solution or transmitted through it. And this picture here is a compartment in the spectrophotometer and shows how a sample contained in a cuvette absorbed light when an incident light from the light source. So this is the incident light from the light source of the spectrophotometer is made to pass through it. And it can also be seen from the picture here that the intensity of the transmitted light as shown here after the incident light from the light source of the spectrophotometer is made to pass through the test solution contained in a cuvette is less than that of the incident light, because the sample contained in the cuvette here will absorb a portion of the incident light as it passes through it. So the amount of light absorbed by this test sample is what is measured by the spectrophotometer as an absorbance value. Let's look at some key informations on the spectrophotometer. And before we do that, the diagram or the picture here shows the basic parts of the spectrophotometer. So from this diagram, so we can see that the light source, the lens, the monochromator, the wavelength selector or the slit, the sample compartment, the photocell, and the digital display board or meter forms the basic parts of the spectrophotometer. So the first information that we have to note about the spectrophotometer is that it is made up of two different instruments or devices, and these are the spectrometer and the photometer. So what we also have to note is that the spectrometer emits light of a desired wavelength, whilst the photometer detects or measures the amount of light absorbed or transmitted through the test sample. Also, the spectrophotometer is designed in such a way that the compartments where the test sample is placed, and this is the compartment where the test sample is placed, is between the spectrometer and the photometer and works by passing a light beam of a particular wavelength through the test sample and measuring the intensity of the absorbed light and display the value on a digital display meter as the absorbance value. So from this basic instrumentation, so we can see that this is the sample compartment that separates the photometer from the spectrometer. And the importance of the sample compartment is to hold our sample contained in our cuvette for measuring the absorbance value. And again, so the light source, the lens, the monochromator, which is either made of prism or grating, the slit and the wavelength selector are the component of the spectrometer. So whilst the photocell and the digital display board or meter forms the component of the photometer. Look at the basic parts of the spectrophotometer and their importance. So the first part is the light source. So the light source emits the type of light needed for measurement. And this can be a UV light or visible light or an infrared. And what you have to notice is that the type of light emitted by the light source is a polychromatic light. So the next basic part is the lens. And the lens focuses the polychromatic light from the light source onto the monochromator. So let's look at the third basic part, and this is the monochromator. So the monochromator splits or disperses the polychromatic radiation into its component wavelengths or bands of wavelengths. So the next basic part is the wavelength selector, and this is the wavelength selector. So it selects the desired spectrum of light emitted from the monochromator at the required wavelength. And the next basic part is the sample compartment. And the sample compartment is designed to hold the cuvette containing the solution of the test sample. The next basic part is the photocell, and the photocell measures the amount of light absorbed by the test solution or transmitted to it. And the last basic part is a digital display meter or recorder or board, and this records and displays the result from the detector. So let's see how the spectrophotometer measures absorbance values. So first of all, the lens receives a polychromatic radiation from the light source and focuses it onto the monochromator, which is made of a prism or grating. So once this happens, the monochromator then splits or disperses the polychromatic radiation into its wavelengths or bands of wavelength as a monochromatic spectrum, as shown over here. The exit slit or the wavelength selector then selects the desired spectrum of light dispersed by the monochromator at the given wavelength and allows it to pass through onto the test solution contained in the cuvette. So what happens is that in the test sample solution, an amount of light is absorbed and the rest transmitted to the detector or the photocell. The detector or the photocell then detects and measures the amount of light absorbed by the test solution or transmitted through the test sample and display it as an absorbance value on the digital display board or meter as shown here. So finally, let us look at the light sources or the type of lights used in the UV visible spectrophotometer. So first of all, what we have to note is that the UV visible spectrophotometer is a type of spectrophotometer that is able to measure absorbance values at wavelengths within the ultraviolet radiation range and the visible light spectrum range. So for measurement in the ultraviolet range, the hydrogen lamp or the deuterium lamp are commonly used, and also the xenon lamp may also be used, but the disadvantage here is that the radiation produced by the xenon lamp is not as stable as that of the hydrogen and the deuterium lamp. And also for measurement in the visible range, the tungsten filament lamps are most commonly used.